All right, let's talk about upgrading your research toolkit. We're going to demystify 4 really powerful statistical methods designed to handle the messy, complex questions that we all want to answer. You know, when you're doing research in fields like education or linguistics, it's never just a simple one cause, one effect situation, right? The real world is, well, it's messy. Everything's interconnected. So the big question is, how do we actually make sense of all that? Well, let's dive into the tools that can help. Okay, first up, what do you do when you have to handle multiple outcomes? So let's imagine you've got this great new teaching method, and you're pretty sure it's not just improving writing scores, but it's also boosting speaking skills and building student confidence. That's awesome. But how do you test all of those things at the same time without messing up your results? Well, the answer is a tool called MANOVA. That's multivariate analysis of variance. Just think of it like a supercharged ANOVA. You know how ANOVA looks at just one outcome? MANOVA lets you look at 2, 3, or even more, all at the same time. It asks a bigger question. Do these groups differ on a whole combination of things? Now, you might be thinking, why not just run a bunch of separate ANOVAs? And that's a good question. But here's the catch. Every time you run a test, you increase your risk of what's called a false alarm, basically finding something that isn't really there. MANOVA is so cool because it protects you from that. It bundles all your outcomes into this one super variable and then runs a single, much more powerful test. Okay, so when you're looking at MANOVA results, the big number you're looking for is called Wilks lambda. All you really need to know is this. A smaller value is better, way better. It means there's a stronger, more significant difference between your groups. So if you see a Wilks lambda that's getting close to 0, that's your aha moment. A small number here is a really big deal. All right, let's move on to our second big challenge. And this one is all about fairness. How do we make sure we're making fair comparisons? So, picture this. You're testing a brand new learning app in one class, and you've got another class as your control group. Seems simple enough. But wait, what if the first class was already full of higher achieving students right from day one? Any difference you see at the end, well, it might have nothing to do with your app. It could just be that they had a head start. And that is exactly where our next tool comes in. Really, its entire job can be boiled down to just this one idea. It's all about making the playing field level. The solution here is ANCOVA, or analysis of covariance. It's this really clever blend of ANOVA and regression. What it does is it lets you take that initial difference, say a pretest score, and mathematically factor it out. It's like it statistically adjusts the final scores to show you what would have happened if both groups had started from the exact same starting line. Pretty cool, right? Okay, moving on to a situation that is super, super common, especially if you're in social sciences or education. Just think about it for a second. Students in the same class, they're not really independent, are they? I mean, they've all got the same teacher, they're in the same room, they share the same experiences day in and day out. This is what we call nested data, and it actually violates a huge assumption in a lot of basic stats. If you ignore it, you could totally skew your results. The tool built specifically for this problem is called hierarchical linear modeling, or HLM. It's designed to handle this nested structure by looking at data on multiple levels at the same time. So it can separate out what's going on at the individual student level, like their personal motivation, from what's happening at the classroom level, like how good the teacher is with technology. So how do you even know if you need to use HLM? Well, there's a pretty simple test you can run called the Intraclass Correlation Coefficient, or ICC. All it does is tell you how much of the difference you're seeing is because of the group they're in. And here's the rule of thumb. If that number is bigger than about 0.05, that's a huge red flag. It's telling you, hey, the group effects are real and you absolutely need HLM to get this right. Okay, for our last tool, we're going to think really big. I'm talking about testing an entire theory, not just one little piece of the puzzle. You know how researchers love to talk about these big abstract ideas, right? Things like growth mindset or motivation or anxiety. Well, you can't just measure those with a ruler or a single survey question. They're called latent variables. So the real challenge is, how on earth do you test a complex theory that connects all these big, unmeasurable ideas? This is a job for the powerhouse of our toolkit, Structural Equation Modeling, or SEM. This thing is amazing. It lets you test a whole chain of relationships, an entire theoretical model, all in one go. You can literally test a story like, does having a growth mindset lead to lower anxiety, which in turn leads to higher engagement, which then leads to better achievement? SEM can test that whole pathway in a single powerful analysis. All right, let's wrap this up and pull everything together into your brand new advanced stats toolkit. So here's your quick and dirty cheat sheet. Just think about the problem you're facing. If your project has a whole bunch of different outcomes, boom, you need MANOVA. If you're comparing groups that weren't really equal to begin with, ANCOVA is your friend. It'll level that playing field. Got data that's nested, like students inside of classrooms? That's a job for HLM. And finally, if you need to test a big, complex theory with lots of moving parts, you bring out the big guns, SEM. And that's our toolkit. You know, the biggest takeaway here is that even though these methods sound complicated, they're not just for stats wizards. They're real, practical tools. Tools that let you ask and actually answer the kind of messy, nuanced, and frankly more interesting questions about how the world really works. So the only question left is, which complex problem are you going to solve first?